so for the next part, we're going to have to solve for y to continue to work within these tables. And before we do that, I'd like to take a little quick review of literal equations, okay? If you recall, in literal equations, we would give you directions like solve for y, and then we would give you an equation that looked like this. 2y plus 5x equals 14. And solving for y means make it say y equals. So my first step would be to subtract 5x from both sides. And I'm left with 2y equals negative 5x plus 14. Then divide both sides, or everything, by 2. In so doing, I get y equals negative 5 halves x plus 7. So if I am ever given a linear equation that looks like this, 2y plus 5x equals 14, that is to say the y's and the x's are on the same side, or the y is not all by itself, you need to transform it so that the y does get in all by itself. And that's what literal equations were all about. We did that work earlier in the year. So here's another one. Solve for y. Go ahead, we'll do stop and start now. Okay, so I want to get y by itself. Solve for y means get y by itself. So I subtract 6x from both sides. 3y is negative 6x minus 12. Then I divide everything by 3. Y equals negative 2x minus 4. Okay, so now we're going to give you this that says 4y equals negative 8x plus 12. And I can't complete the table the way it is now. I have to make this say y equals. So what do I have to do to make this say y equals, to work like I would with a literal equation? Well, I've got to divide everything by 4. So to get y by itself, I divide by 4, and then I get y equals negative 2x plus 3. Now this looks like what I've been doing, and now I can generate the table just like before. Pick some x values. I'll go negative 1, negative 2 to 2. Plugging in the x values into the new equation, negative 2 times negative 2 is 4, plus 3 is 7. Negative 2 times negative 1 is 2, plus 3 is 5. Negative 2 times 0 is 0, plus 3 is 3. Negative 2 times 1 is negative 2, plus 3 is 1. And negative 2 times 2 is negative 4, plus 3 is negative 1. This is also an extremely important skill to have, which is why we taught the literal equations earlier and why we review it now. Because the only way to input, you can't put the equation 4y equals negative 8x plus 12 into your graphing calculator where it says y equals. You need to make it say y equals, that is to say you need to solve for y. So you would have to input y equals negative 2x plus 3 into y1. And once you do that, it would generate the table for you and give you the points. Once I get the table, I know my first point is negative 2 comma 7, then negative 1, 5, then 0, 3, then 1, 1, and 2, negative 1. So I plot my points. And then I connect the dot. And there's my line, okay? So the only thing slightly different now is I need to look at the equation that I'm given, the linear equation, and I need to say, hey, wait a minute, does it say y equals? Because if it doesn't say y equals yet, I need to transform it so that it does. Okay, let's do the next one with a stop and start. Okay, so the problem here is that it doesn't say y equals, it says y minus x equals. So I can add x to both sides, and I get y equals x minus 2. And there is my rule for completing my table. Again, I pick from negative 2 to 2, and plugging them in, the first one will be negative 2 minus 2, which is negative 4. Negative 1 minus 2 is negative 3. 0 minus 2 is negative 2. 1 minus 2 is negative 1. And 2 minus 2 is 0. Now I plot the points. And I connect the dot. And there's my graph. Okay? All right. You try the next one. Go ahead. Stop and start, of course. Okay, so I wanted to say y equals. So first I add the 3x to both sides. Ooh. And then I divide by 2. And I get y equals 3 halves x minus 2. So that's the rule I'm going to follow. What values will I pick for x? Well, this time I better pick values that are all multiples of 2, so the 2 can divide into it. So I go -4, -2, 0, 2, and 4. And that would mean 3/2 times -4 minus 2. So 3/2 times -4 works out to be -6 minus 2 makes -8. 3/2 times -2 is -3, minus 2 is -5. 3/2 times 0 is 0, minus 2 is -2. 3/2 times 2 is 3, minus 2 is 1. And 3/2 times 4 is 6, minus 2 is 4. Now I go over and I plot each of the points. -4, -8. -2, -5. 0, -2. 2, 1, 4, 4. And I connect the dot. If your points don't line up in a perfectly straight line, then there's absolutely something wrong with how you're graphing them. Okay? Now, the next thing I want to do is just go over some review questions. All right? I always like to cycle back, make sure we get a chance to review everything we're doing. So here are some factor each of the following questions. We'll do stop and start. I'll give you the correct answers. Okay, so the first one is one where they share a greatest common factor of 5. So I get 5 times 2n plus 7. As always, check yourself back by multiplying. 5 times 2n is 10n. 5 times 7 is 35, so I'm good. Next one, they share not only a number in common, but also a letter. They share a 3 and a d. So I factor out my greatest common factor of 3d, and then that leaves me with a d left. Because remember, d squared is dd, and if I take out one of those d's, there's one left. And then, of course, when I divide out the 3 from the 15, I have -5, and the 1d already came out. Distribute back. 3d times d is 3d squared. 3d times -5 is -15d. Next up, x squared plus 2x minus 15. Using the AM method, I'm looking for two numbers that multiply out to -15, add up to 2. If you're doing it on the graphing calculator, under y1, you're going to put -15 divided by x. Under y2, you put that plus x, and you're looking for 2 in the last column. When you do that, either way, you will get a +5 and then -3. So it's x plus 5 times x minus 3. Quick mental check. I'm not going to mental check after this one, but I do want to review how to do it. X times x is x squared. X times -3 is -3x. 5 times x is 5x. And 5 times -3 is -15. 5x's and -3x's add up to 2x's. Okay, for the next one, I'm looking for two numbers that multiply out to 27, add up to -12, or in the calculator, under y1, it's 27 divided by x in parentheses, and then in y2, in parentheses, 27 divided by x plus x. Looking for -12 in that last column. If I do that, in the previous columns, I will see -9 and -3. Okay? For the next one, I always look for a greatest common factor. Always. What do you do before you cross the road? Look both ways. What do you do before you factor? You always look for a greatest common factor. In this case, there is one. It is 4. That leaves me with v squared minus v minus 12. So now I need two numbers that multiply out to -12, add up to -1, and they are -4 and 3. Now, taking a look at number 6, I want to factor out 3n squared plus 10n minus 8, and in this one, there is no greatest common factor to factor out. See, plan A is always to get that greatest common factor out of there. When it doesn't exist, we go to plan B, which in this case means I'm going to take that 3 in the beginning, I'm going to multiply it by the -8 at the end. When I wrote C above, that was so that you could follow the work over here. So the 3 times -8 gives me -24. Then I just factor this as usual. Two numbers that multiply out to -24 add up to 10. That would be 12 and -2. If you did it on the calculator, it would be -24 for y1, -24 divided by x, and in y2, in parentheses, -24 divided by x plus x. Look for 10 in the last column. The two previous columns will say -2 and 12. But I did change the question here when I took the 3 and I multiplied it by the number at the end. So now I have to divide back in by 3. I cannot simplify 2/3, so I'm going to take the 3 like we used to do with improper fractions, multiply it in front, and I get 3n minus 2, and then 12 over 3 reduces to 4. So there are my correct factors, 3n minus 2 times n plus 4. Okay? All right, so now we get to talk about some questions that we got wrong on past quizzes and tests. The first one is about expressing an interval notation. Remember, whenever you see an or equal to on the bottom, that means we're talking about a staple. Okay, remember the top and bottom of a staple have that little line that's on the bottom on those top and bottom of the staples. So we know the choice has to be B or C. 8 does not have that little line, so I want it to be a parenthesis. Choice C is the correct answer. Bracket, parentheses. Choice C is the correct answer. Try this one. You express that in interval notation. Go ahead. Okay, so in this case, they both have the little lines underneath for or equal to, so they should both have brackets, -5 and 2. Okay? Next one to check up on. Find 3 consecutive even integers such that 5 times the first plus twice the second and 3 times the third is 96. Realize I underlined all the important parts. So, we'll do stop and start. You solve it. We'll go over it. Okay. I love to underline because that focuses my mind on the important things, okay? And it gets me off writer's block. It says 3 consecutive even integers. So the first one is always n. The next one, because evens you go up by 2's, so it's n plus 2, and then the third one will be n plus 4. And it's 5 times the first. I love writing these words out. See how I wrote that? 5 times the first plus twice the second plus 3 times the third equals 96. And then I just write 5 times the first. It says the first right there. It's n. So 5 times n is 5n. Then it says twice the second. Ooh. Twice the second is 2 times n plus 2. And then it says 3 times the third, which is 3 times n plus 4. And I have to get 96 out of that. So first I distribute. 2 times n is 2n, 2 times 2 is 4, 3 times n is 3n, 3 times 4 is 12. 5n plus 2n is 7n, plus 3n is 10n, and 4 and 12 make 16. So 10n plus 16 is 96. Subtracting 16 from both sides, I get 10n equals 80. Dividing by 10, I get n is equal to 8. So my 3 consecutive integers are 8, 10, and 12. Okay. Now we get into some geometry applications. Let's have you try these 2 questions with some stop and start, and I'll go over the correct answers with you. Go ahead. All right. So, one angle of a triangle is 4 times the first angle. The measure of the third angle is 20 more than 3 times the first angle. Find the angles. Always like to draw that diagram. Here's my first angle. And then it says the next angle is 4 times the first angle. And then it says where 20 more than 3 times the first angle. So what I know about the 3 angles of a triangle is they all add up to 180. So n plus 4n, first angle, second angle, third angle, 3n plus 20, equals 180. 1n, 4n, and 3n add up to 8n's. Plus 20 is 180. Subtracting 20 from both sides, I get 8n is 160. Dividing by 8, I get 20. But that's not the answer to the question. And one of the big problems that every math class I've ever taught in my life, and I think every math class that any teacher's ever taught in their lives, is that kids often stop here because they're so used to solving equations. Oh, I got the answer. I'm done. But as Mr. Braze would have said, oh, what are they asking for? So they're asking for finding all of the angles. So the first one is 20. The next one is 4 times 20, which is 80. And the next one is 3 times 20 plus 20. So 3 times 20 plus 20, it says equals 60. It should say equals 80. And if you look here, 20, 80, and 80 add up to 180. Next up, 2 complementary angles are in the ratio of 2 to 7. As soon as I read that, I automatically say 2n, 7n. Guaranteed every time. Find the measure of the largest angle. Well, what does complementary mean again? Complementary means they add up to 90. So 2n plus 7n is 90. 9n is 90. Dividing by 9, n is 10. So the 2 angles are 20 and 70. Okay? Answer is 70 for the biggest angle. All right. Last little bit of review, we already kind of reviewed earlier today with literal equations. The first one is exactly like what we did. And the second one's a little bit different because there's a square involved there. So let's see you solve each of those equations for y. Let's do stop and start. Okay, so in the first case, I got to get y by itself. That's what solve for y means. Make it say y equals. So I subtract the 2x, and that gives me negative 2x plus 15h on the other side. And that's really strange, but it is what it is, you know? Now I divide by 5, and I get this very strange looking answer, y equals negative 2/5 x plus 3h, because 15 divided by 5 is 3. And I know it looks weird, but it doesn't matter, because you've gotten it to say y equals, and you are correct for doing that. Next one, got to get y by itself. And this is even going to be a little stranger. I'm going to add 8x to both sides. And I get 2y squared equals 8x plus 10n. Still got to get y by itself. So I'm going to divide by 2. And I get, oh man, this is strange. I get y squared equals 4x plus 5n. I'm not used to that. I'm used to it saying y equals. Well, this has always been about inverse operations. Like it said plus 2x up here, I did minus 2x. Here it did minus 8x, I did plus 8x. Here it said 2 times y squared, I divided by 2. So the inverse of squaring is to square root. So I square root y squared, and I square root 4x plus 5n. The cool thing is the square root of y squared is just y. So I get y equals the square root of 4x plus 5n. And that's about as challenging as a literal equation we'll ever get in this particular class. All right, good job. Lesson complete. We'll post the homework and you can work on that later. Have a good one. Bye.